Okay, we'll continue with electrochemistry, a more of a theoretical part to be covered here. Okay, and please do make notes or take snapshots in whatever ways possible and enhance your knowledge. Okay, so what we finished off with in the earlier slide was metallic conductance and electrolytic conductance. So we know that metallic conductance is due to the free flow of electrons within a metallic conductor, and electrolytic conduction is because of free flow of ions within an electrolyte. Okay, so metallic conductance decreases with temperature. If you increase the temperature, obviously there will be more collisions within the metallic surface, within the metallic body, and electronic collisions basically will promote resistance. So the resistance of the conductor will increase, and hence the electrical conductivity will automatically decrease. So when there is a free flow of electrons, the electrons are not being impacted, but the moment we raise the temperature, the flow of electrons gets impacted by the resistance shown by the conductor. Okay, so metallic conductance decreases with temperature and electrolytic conductance increases with temperature. Why will this increase? Because see, electrolytic conductance is because the flow of ions. When you increase the temperature, the ions gain energy and they start flowing with a much higher speed. Here it is purely due to flow of electrons. The electrons get obstructed by other electrons which gain energy and kind of promote collisions. But here there is no collisions. The speed with which the ions move, see the speed, the ions are already there in solid state as well, but they are not free to move. When we make them in a fused state, or rather when we get them into an aqueous solution state, they become free to move. Now when we increase their energy by supplying heat to them, they become more free to move. So in that case the temperature will increase if we happen to increase that, if in electrical conductance or electrolytic conductance, if we happen to increase the temperature, the flow of ions will increase, the rate at which the flow will increase. Okay, so electrolytes ionize in different extents in their aqueous solutions. Okay, now electrolytes will ionize in different extents. Not all electrolytes will undergo 100% dissociation. Okay, so on the basis of how much an electrolyte ionizes when it is put in solution or in a molten state, that will become the deciding factor of conductance through that electrolyte. So electrolyte ionize in different extents in their aqueous solutions. We have strong electrolytes and we have weak electrolytes. Strong electrolytes, they completely dissociate into ions in solution. When we are making solutions of them, they completely dissociate into ions. And let's say we have examples here: NaCl, KCl, then we have NaOH, then we have NH4NO3, okay, sodium chloride, potassium chloride, sodium hydroxide, ammonium nitrate. All these basically are strong electrolytes, which means that they undergo almost 100% dissociation in their respective solutions. However, this doesn't happen with weak electrolytes. So strong electrolytes go 100% dissociation. Weak electrolytes do not ionize completely in solution. They do not ionize completely in solution. For example, we have acetic acid, weak acids, weak bases. Okay, weak acids or weak bases, the reason we call them weak acids or weak bases is because they do not ionize completely to form H plus or OH minus ions, which means that these are basically not undergoing 100% dissociation. A part of it will be retained in the original electrolytic form. So what happens is that the dissociation will happen, but after a certain point of time it is going to stop. Okay, and how do we recognize this? The unionized electrolyte and the ions, they will attain an equilibrium. After some stage they will attain an equilibrium. The unionized ions and the electrolyte itself, there will be an equilibrium that will be established, which means that neither the reaction will go in a forward direction, neither it will come in the backward direction. Whatever had to happen in the form of ionization has already happened. Now it's not going to go further. So the unionized electrolyte, which means the original electrolyte which is not ionized yet, and the ions, they attain an equilibrium state in case of weak electrolytes, and an equilibrium is established. So neither the reaction is going to go in a forward direction, nor it is going to come back in a backward direction, and this happens in the case of weak electrolytes. Okay, in case of strong electrolytes, it's always in the forward direction and the ions keep on forming till it is completely 100% dissociation. So the extent of ionization of a weak electrolyte is expressed in terms of degree of association. We have already studied this in lower classes. But again, the extent of ionization of a weak electrolyte is expressed in terms of degree of ionization. What is the degree of ionization that has happened, or degree of dissociation? Okay, so it is the fraction of the total number of molecules of the electrolyte which ionize in the solution. It is the fraction of the total number of molecules of the electrolyte which basically ionize in the solution, and it is represented by alpha. Okay, so for strong electrolytes, alpha is generally equal to 1, whereas for weak electrolytes, the alpha will be less than 1. So if you see the alpha part, alpha is what? It is the fraction of the total number of molecules. The part of the total number of molecules which have dissociated to form ions is represented by degree of ionization, or we also call this as a degree of dissociation. This is called degree of ionization or degree of dissociation, and this is called alpha. So it is represented by the alpha, and in case of strong electrolytes, obviously 100% dissociation happens, so this fraction is going to have a value of 1, and in case of weak electrolytes, the 100% dissociation is not going to happen, so obviously the value of alpha will be less than 1. This is how it goes. Okay, so this is again a little bit of theory part in electrochemistry. I would prefer if you can take a snapshot of the same and make a note of it somewhere, while we'll continue with the other slides out here. Okay. Okay, we'll continue with the more on electrochemistry, and what are the factors which basically influence the conductivity of electrolytes. Okay, so factors affecting the electrical conductivity of electrolytic solutions. When we have electrolytic solutions, there is certain amount of conductivity that happens. Okay, and that is based on certain factors. So interionic attractions. Okay, now when solute particles are dissolving in solvent, so there can be solute-solute interactions and solvent-solvent interactions and solute-solvent interactions as well. Okay, so we have three particles, the solute-solute interactions. Now when the solute-solute interactions, interionic attractions, now the solute-solute interactions, if the solute-solute interactions are more, if they increase, then the dissociation will decrease. Obviously, if the solute-solute interaction happens more, I'm sorry. So if the solute-solute interactions are more, if the solutes get interacted more, then what will happen? This will result in the decrease in the dissociation, because now it is difficult to dissociate them. Okay, see, generally there is already a bonding between the positive and the negative, and if there happens to be a bonding between the solute particles as well, then this will make the dissociation more or less more difficult. Okay, so interionic attractions can be solute-solute interactions. If the solute-solute interactions become more, then what will happen? The dissociation will decrease. Okay, what do we have next? Solvation. We call solvation of ions. Now solute-solvent interactions, if the solute-solvent interactions are more, then what will happen? The solute-solvent interactions are more, then ions of the solute will be highly solvated, electrical conductivity will become low. So they will become associated with the solvent molecules, because of which the electrical conductivity is going to drop down. Okay, so whether it is solute-solute interactions or whether it is solvent-solute interactions, if they are going to become more, then obviously the electrical conductivity is going to go down. Okay, viscosity of the solvent. Now what do we mean by viscosity? We more or less know from physics that viscosity is basically liquid or fluid friction. Okay, now it is basically the friction that exists between the different layers of the liquid. So when the solvent-solvent interactions are more, obviously when the solvent-solvent interactions are more, for example, if you look at mercury, it has high viscosity because it is very thick. Okay, so the layers of mercury have much of interaction. When the solvent-solvent interactions are more, then viscosity of the solvent is going to be higher. Okay, so all these above factors, if you notice, they happen to increase with temperature. All of the above factors, basically, if you increase the temperature, then they decrease, and hence the it will impact the electrical conductivity. So if you increase the temperature, they all will certainly decrease. With the increase in temperature, they will decrease, and if they decrease, what will happen? Electrical conductivity will become more. Okay, because if the solute-solute interactions decrease with temperature, then the solute or the ions will be more readily available. Okay, if the solute-solvent interactions decrease with increase in temperature, then what will happen? The ions will be more available. If the viscosity of the liquid decreases or the solvent-solvent interaction decreases, then what will happen? The ions will be able to freely move. Okay, and hence the conductivity will increase. So these are the primary factors: solute-solute interactions, solid-solvent interactions, and solvent-solvent interactions. Okay, solute-solute interactions, if temperature increases, it decreases. Solute-solvent interaction, temperature increases, it decreases. Solvent-solvent interactions, which results in viscosity, if the temperature increases, then it decreases. Okay. So factors affecting the conductivity of an electrolyte. What are the factors which affect the conductivity of an electrolyte? Obviously the nature of the electrolyte, how strongly it can form ions. More the number of ions, more the conductance. And we all know, for example, strong electrolytes will form more ions, weak electrolytes will form less ions, because after a certain stage, strong electrolytes are supposedly forming 100% of their ions, because that is considered to be a 100% dissociation. Whereas weak electrolytes, there are less ions, okay, which are getting formed. Okay, now nature of the solvent, higher is the polarity of the solvent, larger is the ionization. The more is the polarity of the solvent. For polar solvents, for example, water is a polar solvent. More is the polarity of the solvent, more strongly the ions will be formed, and more will be the electrical conductivity. So obviously nature of the electrolyte is one thing. Okay, it can be a strong electrolyte, it can be a weak electrolyte. It depends on how much of it dissociates when it is dissolved in a solvent, in a particular solvent, or in a fused state. Okay, nature of the solvent means higher is the polarity of the solvent in which the solute is getting dissolved or the electrolyte is getting formed, higher will be the ionization. Okay, and more is the conductance. Okay, size of the ions produced and their solvation. If the ions are strongly solvated, effective size will increase. Okay, if the interaction, see, the size will increase. Basically what will happen is, if the solute particles interact more with the solvent particles, their size is going to increase, and that will reduce the conductance. Okay, the effective conductance will basically decrease. Concentration of electrolytic solution, more you make the solution dilute, the better it will be. Okay, concentration of electrolyte, molar conductance of an electrolyte increases with increase in dilution. More is the dilution, more is the conductance. The fourth factor on which it depends basically will be temperature. And as we saw that with a temperature increase, if you happen to increase the temperature, the conductance of an electrolyte also increases. Its conductance is also going to increase. Okay, so these are certain factors which will influence or affect the conductance of an electrolyte. Please take a snapshot of the same, and if you can make a note, well and good, and we'll proceed with the next slide. Right, we are going to continue with electrochemistry. Now, what is, see, till now in electrochemistry, or rather when we study about electrolytes, when we study about cathode and anode, we have different perceptions about it, and those perceptions are generally not the strongest of perceptions that we should be having about electrochemistry. So things are going to change a little, or how we see a cathode or an anode are going to differ now. Okay, so till now cathode was considered to be a negative terminal, and anode was considered to be a positive terminal. That's what we have learned in wherever we have learned electrochemistry. Now these things are going to change. So cathode basically means a terminal where reduction happens. Okay, and anode basically means a terminal where oxidation happens. This is very important, keep it in mind, because if this is clear, then I don't think we will have much of problems in electrochemistry. So cathode is basically a terminal wherein reduction occurs, and anode is basically a terminal wherein oxidation occurs, and this is very basic. Okay, now when we come to electrochemistry, what is it that we are going to study in electrochemistry? The first thing that we are studying here is basically electrical energy, which is getting converted into chemical energy. So we study the interconversion between electrical and chemical energy. Okay, so we try to understand how this interconversion is basically happening, and this interconversion is having a definite path from electrical energy to chemical energy, or from chemical energy to electrical energy. So when we have electrical energy to chemical energy, it is an electrolytic cell, and when chemical energy gets converted into electrical energy, it is considered as a galvanic cell. So just remember these terms. Okay, when electrical energy is getting converted into chemical energy, it is an electrolytic cell, Okay, so just a way to remember is both start with E. Okay, electrolytic cell, where an electrical energy is getting converted into chemical energy, and when chemical energy is getting converted into electrical energy, it is called galvanic cell. Okay, all right. So what we have here is electrical energy is converted into chemical energy. This is called electrolytic cell. Electrical energy is converted into chemical energy. Okay, so we are trying to understand how an electrolytic cell works. Okay, so first of all, as we have studied here only, the electrical energy is getting converted into chemical energy. Okay, in electrochemical reaction, non-spontaneous redox reaction occurs in electrochemical cell. So basically, what is non-spontaneous? Non-spontaneous is a reaction which will not happen by its own. Okay, so in electrochemical cell, non-spontaneous redox reaction occurs. So there is a redox reaction which will happen, which means that reduction and oxidation both will happen. However, they have to be triggered. They cannot happen on their own. Okay, so you will have to kickstart it with some amount of energy. Okay, now there is something called as Gibbs free energy, which we have studied in earlier classes, but just to kind of confirm. See, Gibbs free energy is basically the energy which is required to do useful work, which means that there will always be an extra amount of energy in any type of system, a compound, an element, whatever. Okay, whenever there is an extra amount of energy, that extra amount of energy is actually used to maintain the stability of the system, and when we happen to remove it, the thing that remains is basically Gibbs energy. So enthalpy is basically the total energy which is possessed by a system, and when we happen to deduct the T delta S, which means energy which is required to maintain its free state, energy which is required to maintain its free state, when we deduct this amount of energy from the total enthalpy, what we have left over here is Gibbs energy. Okay, so let's understand this by means of an example. So let's say if there is a farmer, and the farmer has basically 4 sons. Okay, 4 sons, and he has a field. Okay, he has a field, so this field has to be basically plowed and irrigated and all. So the farming products will be available from this field, whatever crop cultivation he is doing. Okay, so let's say his production is 1000 tons for a year. Okay, 1000 tons, whatever crop he is. Okay, now when he is employing these 4 sons along with himself, of course. Okay, when he is employing these 4 sons, he is getting 1000 tons. Okay, and let's say supposedly, so whatever earning he does after producing 1000 tons, he sells it to the market, whatever he earns out of it, that's basically his earning. And if he happens to send these 2, if he keeps 2 sons with him for plying and all irrigation work, and the 2 remaining sons he sends him or he sends them to somewhere else to earn money. Okay, let's say to a town or maybe to a city in order to earn money, so that there is an additional income, or rather they can leave him and set aside. Okay, still his production will be 1000 tons. So what he is trying to do here is he is subtracting these 2 sons from the labor that he is employing, okay, for the production that he requires. So even without those 2 sons, he will be able to maintain his production of 1000 tons, and that's what is happening. Okay, subtraction is basically what is useful work. Okay, by subtracting these 2 sons from the workforce that he has in order to produce this type of crop cultivation, or this magnitude of crop cultivation is not impacting his production. Okay, so he is subtracting it, subtracting the energy which is required to maintain its free state. So from a system we are subtracting that energy. What are we having? Useful work done. Useful work done still remains the same. So energy which is required to, so in a particular system there is something called as enthalpy, or the total energy of the system. So this delta H is basically the total energy of a system. Okay, so total energy of a system, and there is some amount of energy which is required to maintain the free state of the system. If we happen to subtract this energy, what we are left with is the Gibbs energy, the energy which is required to do useful work. So understand what is Gibbs energy. Gibbs energy is basically the energy in a system which is required to do useful work. Some extra amount of energy that is available to the system is just to ensure its stability. Okay, that's what we mean by Gibbs energy. Now, in this system, which is basically a non-spontaneous system, in an electrochemical cell, we are supplying some amount of energy. So, on top of Gibbs energy, we are supplying some more form of energy. Okay, so for a non-spontaneous process, Gibbs energy will always be positive because you are adding on energy to it. The Gibbs energy will have an addition to it. So here the Gibbs energy is going to be positive. This Gibbs energy for a non-spontaneous reaction means basically an electrochemical cell. So this is going to be positive. Whereas for a spontaneous reaction which happens on its own, obviously this Gibbs energy will get reduced in that system. So there are certain reactions which happen on their own which do not need a kick or a start from external sources. So in that case the Gibbs energy will be negative. Now since this is basically a system which is acquiring energy from outside, obviously the total Gibbs energy that will be available will be positive. Okay, so this is something that we need to understand. So these are characteristics of an electrochemical cell. We will cover more of these characteristics in the next slide, but what we understand from here is that it is a non-spontaneous reaction and hence Gibbs energy is going to be positive. Okay, electrochemical cell, again what is it? Electrical energy here is getting converted into chemical energy. So obviously to the system we would be supplying electrical energy, and this electrical energy, since it is supplied to the system, it will actually enhance the Gibbs energy and make it positive. Alright, so these are certain characteristics of electrolytic cell. More characteristics will be covered in the next slide that we will have. Okay. Okay, so what we have here is the Gibbs energy. That's what we were discussing in the last slide. So Gibbs energy is basically the energy that is left over in the system to do useful work. And when we are talking about an electrolytic cell, we are supplying energy to that cell. So it definitely means that this energy is going in increasing or rather positive energy of the Gibbs cell. So delta G is equal to delta H minus T delta S. This is basically thermodynamics. Now electrolytic cell is basically a cell wherein non-spontaneous reaction happens. So no energy is spent by the system. So energy is added to the system. So obviously the working energy of the system will increase, which means the Gibbs energy will increase. So the system energy increases. For a non-spontaneous reaction, Gibbs energy is always going to be positive, and for a spontaneous reaction, Gibbs energy is always going to be negative. Okay, so this is basically a reaction in which we are supplying electrical energy and getting it converted to chemical energy. Now look at this. Okay, so let's say this is an electrolytic cell, and what we have here inside is an electrolytic solution. Now what is an electrolytic solution? Electrolytic solution is basically a solution which is made up of ions. What are the ions that are involved here? The cation and the anion. So cation and anion is basically used, or rather in the solution. So in an electrolytic solution we will have cations and anions. Okay, so cations is basically the positive charge and the anions. So if we look into an let's say now in this electrolytic solution we dip two rods. Okay, we dip two rods, any inert rod basically, any inert electrode basically. This is an inert electrode, let's say platinum. Okay, platinum is an inert metal. We all know gold, silver and platinum, they do not generally react with chemicals. Okay, so we can select a platinum electrode. So what we have done here is we have taken two platinum electrodes and dipped it in this electrolytic solution, which is made up of these type of ions, the cations and the anions. Ca basically means the cation part and the anion part. So we have the cation part and the anion part. Okay, now we are dipping this. I will go a little. Okay, now let's say this is a battery supply to which we are connecting this to. Okay, so obviously this is the negative side and this is the positive terminal. Okay, generally we say the anode is the positive terminal and the cathode is the negative terminal, but our definitions are going to change in electrochemistry. Not that they are not going to be valid anymore, it's just that the perceptions are going to change. Okay, now look at this, what we have specified and what will follow. Okay, so now what will happen, this negative electrode will push electrons down on this. So this will become a negative electrode, or rather this will become the cathode. Okay, and we will prove that in the cathode the reduction reaction takes place. This will become the anode. Obviously, why? Because this is the positive electrode, so it will pull electrons. This is the positive electrode, so it will pull the positive electrons from here and it will become positively charged. So this becomes the anode. Anode, which is basically positively charged, and cathode, which is negatively charged. Okay. Now in the electrochemical reactions, what is basically happening? So first of all, the electrolyte has reduced to the two components, the cations and the anions. Now when the electrolysis starts, which means that when we have supplied the battery connection and the switch is on, what is happening is that this is becoming a negative electrode and this is becoming a positive electrode. Now what will happen? Obviously in the solution we have C plus and A minus. So what will happen is, at anode, which is the positive terminal, the anions will start moving towards the anode. So A minus will start moving towards the anode. A minus will start moving towards the anode. Why? Because it is the positive terminal. And what will happen at the anode? The A minus, which has an extra of electrons, will actually get its electron released and it will become neutral A. Okay. So what is happening at the anode? Just understand this. See, prior to this we had a perception that anode is the positive terminal, but now we will have perceptions as per the oxidation or reduction reactions. So what is happening at the anode? It is giving away one electron, it is becoming neutral. Okay. So their giving away of electrons is known as oxidation reaction. So at anode the oxidation reaction is happening. Okay. Now since it's half reaction, we will call half oxidation reaction. So at anode the anion is giving away its one electron and getting converted into a neutral atom or element, whatever. So this is called half oxidation reaction. Now what is happening at the cathode? Now obviously this will have C plus ions, so these will move towards the negative electrode. The C plus ions will basically move towards the negative terminal, and what will happen at the negative terminal? The C plus ions will gain electrons to get converted into neutral C. Okay, cations. Now let's look at this equation 1 and equation 2. So if I have equation 1 here as this, okay, this is equation 1, and what is equation 2? The cathode plus electron, one electron, basically gives you what? A cation. It's not a neutral molecule basically. So this and this gets cancelled. What do we have here? A plus plus C minus, sorry, A minus plus C plus is equal to A plus C. Okay. So what has happened here? A minus plus C plus is equal to A plus C. This is basically what? A plus and C minus was what? Basically Ca, the electrolyte. Okay, A plus and C minus was the electrolyte. So when we have subjected it to electrical energy, it has converted both A and C in their pure states. That is what is happening in an electrolytic reduction. So what is happening here? When we are supplying energy to an electrolyte, and that's electrolysis basically, electrical energy. Here the electrical energy is the input and chemical energy is the output. So we are getting two separate products, that is A and C, and these are in their pure states. Okay, no more ions. Just as we have say in NaCl, when sodium chloride is subjected to electrolysis, it will get converted into sodium and pure chlorine. Okay, half Cl2 basically pure chlorine. So sodium and pure chlorine are the products that we obtain. Okay, so this is the concept of electrolytic cell. Okay, wherein we take an electrolyte, we supply and electricity to it. So there is an electrical energy which is the input. This increases the Gibbs energy of the system. Okay, the Gibbs energy will be positive in this system. We dip two electrodes into it. Obviously the cations will move towards the negative electrodes, and the anions will move towards the positive electrodes. And as you can see, as I had defined earlier in this chapter, that at anode oxidation reaction occurs. This is half oxidation reaction. Okay, why half? Because the other half is happening at the other end. Okay, so this is called half oxidation reaction. and this is called half reduction reaction. If we add both of them, what we get is that the electrolyte is basically getting reduced by supply of electrical energy, or rather it is getting converted into its two pure components. Okay, so we are getting the two pure components, that is A and C out there. Okay, I hope it makes the electrolytic cell a little clearer out here. You can certainly post your comments if something is missed by me, or if something needs a reiteration from my end, and we'll take it from there. Okay, you can take a snapshot of the same